Hello, everyone, and welcome to another edition of Simplifying Network Automation with NetGrew. I'm your host, NetGrew, and we have a special guest today, Jeremy Coho. We've had people asking about Google Tech on iOS XE a while back, right? So I'm happy to bring Jeremy to kind of show you GNMI, GNOI, and all these interfaces, what you can do with them. So without further ado, Jeremy, I know you're jumping from another call
No
to
big deal.
this, so I really appreciate you being flexible, and it seems like it's a busy Friday for you.
Oh man, I think it's business as usual, isn't it?
It is these days. Very busy, everyone. So thank you so much for doing this. Really appreciate it. You want to tell folks a couple of words about yourself, about role at Cisco?
Yep, for sure. I think I'm sharing my screen. I don't know. But yeah.
Yes, there you are.
Woo. Okay, great. It looks like all the info is even right on it, so that's even better. Hello everyone. What's up? I'm Jeremy. Working technical marketing at Cisco Systems here for a little over 7 years. I've been covering iOS XE in the campus and enterprise space. I've been supporting the programmability and automation portfolio, which includes the netconf, restconf, and GNMI APIs, as well as the streaming telemetry service as well. So lots of like really fun integrations. And yeah, I guess today we're talking about Google stuff.
Yep.
Okay, what do we talk about? I have
Uh,
an agenda. Here it
you do?
is.
Okay, there you
Yeah,
go.
yeah. So this is what I wanted to say. Like, yeah, let's just like really like I don't know if we've talked about the API really before at like a really high level. So we'll just like make sure we understand what we're talking about, and then double click even more onto the GNMI API. I put a call out in here for the security considerations for like running this stuff in production, which we're not going to go over today, right? We're just going to go into like how this thing works. Let's use it. Let's do a bunch of demos and like see how like what we can do with it. And that's what the GNMI and then GNOI lines here are, which is capabilities get set subscribe. Like we'll go into the tooling and we'll just play around with the API and understand what it does. And then after that, go into the GNOIs, which is like the more advanced or some of the more advanced use cases for this API, which allow us to do like factory reset and like operating system upgrades programmatically. So how's that sound?
Cool. Sounds really good. I'm really curious. I'm learning over here too, so
Okay,
super
so
excited.
great. So this is the programmability and automation lifecycle, like high level view. You've probably seen this before, right? It goes from day zero, which is the like onboarding with ZTP. We have a learning lab for that, as well as secure ZTP, which we're working on. And then we have day one, which is, well, we'll be spending a bit of time today, model-driven programmability, specifically with GNMI. We'll use Cisco native data models. We'll also look at some open config data models. And same thing with telemetry. We'll do actually a subscribe operation. So we'll get data pushed to us from the device, into our tooling. And the tooling that we're going to be using is Yang Suite. So I think we know about Yang Suite. I have a slide here for it. I had a slide here for it, but we could talk about the data models, I guess. So before we do that, let's actually just go into the, should we go into Yang Suite and just like start interacting with the API here?
Yeah, let's have a look at Yang Suite. And Jeremy, your camera keeps
Oh,
flapping. I don't know exactly what's happening.
oh man. Okay, so sorry about that.
It's all
Okay, here.
good.
Oh, here we go. That's the problem here. Okay, so let's go into Safari. Let me just refresh this.
So Yang Suite, right? Let's tell folks what Yang Suite is. Where can they get it? How can they install it? Just there you go.
Cisco Yang Suite. So developer.cisco.com/Yang Suite. This is the tooling that we use for testing and validation, right? Where you can like learn about data models, interact with the device, which is what we're going to be doing with GNMI. We can use telemetry. It's got all sorts of capabilities and stuff in here. We have a couple YouTube videos, and then we have like the forum, the WebEx space, There's a mailer and then GitHub as well. So there's like, you can open issues there. So it's the tooling that we use for interacting with the APIs. In this case, I have my Yang suite installed here. I have my device selected for netconf, but we're actually in the wrong place. We need to go over here to protocols GNMI. And this is going to load the GNMI plugin. So this is going to allow us to interact programmatically with this device over GNMI. So I have my device here. It's 9300. Right? This is my like top of rack 9300 switch here. And I'll select my data models from iOS XE version 17.12. That's the latest shipping version right now. One thing that we can do with GNMI is the capabilities exchange. So when I click capabilities button, it's going to actually go and send the first RPC or API call to this device, to this 9300 switch here. And it's going to give me some info back. It's going to tell me the GNMI version that it's running, 070. So we can go to GitHub, go to the OpenConfig or GNMI repository, and we can go and understand, what's supported in version 0.7, what's the innovation that was added in this version. We can also see the encoding. So we're supporting JSON and JSON IETF. I'm actually running a little bit of an older version of 9300 here. In 17.12, we're supporting one more encoding mechanism here. You know what it is, Adrian?
What? It's XML or what?
No, nice try though. I'll give you a point for that. It's protobuf encoding.
Oh, protobuffing.
Yeah,
Okay.
so it's a more more compact or more efficient way of serializing or encoding the data before we transmit it over the wire. Okay, so that's the encoding, and then here we actually get to see all the data models that are supported. There is like, I don't know, 620 some data models. You'll see a lot of them from iOS XE, right? You'll see all of these operational models for the majority of the features that we're familiar with working with. So the one I've highlighted here is like application hosting, right? But there's also like BGP opper, BGP route oppers, contain all your route information, cable diagnostics operational data. But then we also have all the running config, right, for the individual features. That's modeled in here as well in the actual native data model. In addition to the Cisco models, we have the OpenConfig data model ecosystem down here at the bottom. So here we have like AAA and ACL modeled per the OpenConfig data model ecosystem standard, as well as some other ones from IETF. Right, so this just helps us understand which data models are supported on this device. Let me pause here. Any questions on this capabilities thing? It's very similar to netconf.
It is. Yes, I was about to say that it looks, and of course, I mean, we're supporting, like you said, OpenConfig, IETF models, right? So if you're a customer that uses those types of models in the infrastructure and in their networks, then you can definitely take advantage of these. They're already on the switch. All these models readily available for you. So yeah, GNMI, it's new for me.
Yep. So what's next, right? Well, we understand the capabilities of this thing. Let's actually start interacting with the API a little bit here. So I'm going to do like one of the most common use cases first, which is going to be like understanding like statistics and counters of interfaces on this switch, right? So this is going to be the equivalent of doing like, show interfaces, for example. So I've loaded the operational data model for interfaces. We can see it. Let me just make this a little smaller, maybe.
There you go. Yes.
Okay, how's that?
It's better.
Okay.
Thanks.
So yeah, it's okay. I should also let you know that we're doing a UX redesign. We had a UX consultant come in and give us some advice and do some studies with us. So I'm optimistic we're going to see some improvements to the GUI and the UI in the next couple of releases of Yang Suite. But what we can see here with the interfaces opera model is there's a container and a list. this list is going to be keyed per a name. So if we look at this, we right-click, click on properties, it's going to tell us that this is the name of the interface. Okay, so we're going to get all of this data back per interface, and specifically what we're going to get is all these statistics. Right, we're going to get the most common statistics that most network engineers are going to want to look towards, which is like our packets, in and out packets, broadcast, multicast, unicast packets, all of this like good packet counter stuff. So what I actually want to do here is just put a tick box next to the interfaces container in the value column, and we can build this RPC. Now let's just check some of the settings here that we're going to do a get. We're not using prefixing. This is something that's needed depending on when we're using telemetry. And it says here, refer to the GNMI specification if you need prefixing. What type of get are we going to do? Well, yeah, let's get all. Right? Any data that comes back, I'll take it. It's asking us the origin. So this is the data model ecosystem origin. So is this an open config model? Nope. This is a Cisco IOS XE. So that means we should use the RFC standard 7951. That's the standard data model that we're using within IOS XE. We can also specify the encoding type. We're going to leave it at JSON IETF. We can also, as we were saying, also supports proto, but not on this older version that I'm running here. So we'll select JSON IETF, and we can build this RPC. So when I click build, we get this block of JSON generated for us from Yang Suite, and this is per the Yang data model. So we get this encoding or this payload here, and we can run it. When I click run, it's going to open up a GNMI session to the device. It creates a session, as it says right here, and it sends this get command. Right? This is the same payload that we asked it to, said, yeah, we want interfaces oper. And then we get the response back. Right? We get this one big long line in JSON IETF value. I can scroll for like, weeks here. And okay, but that's not very useful. Let's actually just scroll down a little bit where this data is actually decoded. Right? So now we can actually get some data, some intelligent data out of this, where we can see, our first keyed value, our app gig Ethernet 101. And then we actually see, the packets and the counters, coming in from this interface. And then, we can scroll down. We can scroll down a lot to, the next interface, which is going to be, maybe not the next, but one of these ones here in the middle, 10 gig E1015. And we can see again, some stats and counters are on here, as well as we can see the description that, oh yeah, this port connects to the 9200 switch that's also in the same rack. Right, this is the interface description, right? As just like we can see the description on all of the ports and all the counters on all the ports. So with that, let me just pause here. That's doing a get, right? That's getting operational data from the thing.
So this looks very similar to like RESTconf, actually.
Yep, totally. Very similar to netconf, very similar to RESTconf. And like netconf, RESTconf, GNMI, they all use the same Yang data models. So, regardless of which API interface that we choose, then, it's the same data that comes back. What's different is just formatted slightly different, right? Here, of course, it's formatted in JSON IETF for GNMI. But if we go over here to protocols and netconf, when we load up an API call here, it's going to be using just XML.
Right. And then RESTconf is actually the REST interface, and GNMI is just the RPC interface.
Yeah, and we have done some innovation with the RESTconf plugin recently to have this the Swagger UI. So it's like more point and click, but we're getting a little away from GNMI here now. Okay, so yeah, so we did the get, right? Let's actually go and do some configuration management, because that's really where this API and why we're using APIs is to manage configuration. So let's do the most basic example here, which is working with the running configuration. Now this is going to take a minute to load. It should actually take less than a minute. The engineering team told me that it would take less than 45 seconds. But I'm not actually going to start the timer because yeah, it could be bad. When I ran it last night, it took like over 2 minutes. But they actually said after the first load, it's supposed to be significantly quicker. So we'll see.
Right, because this one basically loads all the config, all the operational data.
This loads the like Cisco native.yang, which has all of the configuration for iOS XE modeled in it. So every feature is its own container that feature teams manage, and that we toggle or work with these features individually. So how many features are there on iOS XE? I haven't counted. I don't know. There's a lot of containers though, so it does take a little bit to load, to parse this data model, as well as to augment and bring in all of the supporting data models. Okay, and here it is, right? So when we actually load it up here, we can scroll down here and we can see, each of these features. We have features for MKA, MACsec key authentication, and IPv6 and VLANs, right? There's tons of features that are supported on this operating system. So this thing is loaded. We can use the search to go and actually find the actual thing that we want to change, right? So in this case, I'm going to do a search in here for hostname. We'll do a really basic configuration management use case here first, which is to work with the hostname. So I did a search for hostname, selected the XPath, which is native hostname, and we can click show selected node. It brings us down here to the hostname leaf. We can right click on this, again, click properties, and it'll tell us, oh yeah, this is the system, the network host name. So when you log in, this is the name that you see. Let's do a get against this thing. Let's understand what's the host name right now. So if I build this RPC, we can see again that we're going to ask for Cisco IOS XE native, and we're going to ask for the host name leaf. Please select a device. Okay, here it is. And let's run this. Okay, so we get our response back and to our question, which is host name. And what's the answer here? Set by GNMI. So that's what the host name is. I guess someone said it last night when they were testing this out. That someone was probably me, right? So that's what it's set to. Great. Let's go change it, right? How do we do that? Well, we do a set operation. Okay. So pretty much everything here stays the same. We just need to go in and put what we want to set this to. So what's the new host name going to be, Adrian? You got to give me something fun to put in.
Oof. NetGroup kicks ass.
Yeah. Kicks it. I'll just put that.
Kicks it. Yeah.
Okay. Okay. So there is the new host name that we're going to use. Here's the payload that we're going to send to the device that's going to set the host name to this value of netgroup kicks it. So let's run this RPC and let's see what happens. So we get a response back saying that we had an operation of an update, right, that occurred at this time. All right, great. So did it work? And we can do some, manual validation here where we go onto the command line and we can see, instantly the CLI or the host name that we were seeing before has been changed to as we sent it. Great, so it worked, right? But let's not actually do validation on a command line. Let's actually just do validation on the CLI, right? Let's do a get command again, where we build the RPC for the host name. And for the get, let's run it again. What's it gonna say? netgroup kicks it. Awesome, right? So this is our example of doing a set update where, we can change the host name.
Cool.
Okay, so what's next? We did the capabilities, the get, the set. How about subscribe? All right, let's talk about telemetry for a little bit. The example that's been top of mind recently is with PoE. And this is the example that I put into the guide as well. And I don't know if I dropped a link to that, but we should. We put it on GitHub. Basically, everything that I'm walking through here, we put into the lab guide so you can follow along. So we're in the subscribe area here now, and the use cases with PoE Opera, right? So this is to understand, how much PoE is utilized on my device. And the reason for this is we want to kind of save power or turn down power if it's not in use. So let's build up this subscribe request. We have a couple different options here. You'll notice once I click subscribe that we have a stream, a once, and a poll, and then we have on change, a sample, or target defined. So these are options that the API supports or has support for. The option that we use with iOS XE is a stream. So this is similar to our periodic subscriptions. And we want to stream this data either on change or on a sample or per what the target defines, right? Target defined, we don't actually have support for this on iOS XE. We do have support for on change. On change is like when an event occurs, like an optic fault, for example, or login failure, we can get an on change notification for that. Also for some routing protocol changes, we get on change notification when neighbors or adjacencies change. But for this data, we're going to be looking at time series data. We're going to be looking at power utilization. So we're going to look at this at a sample, and we want to sample this data every 30 seconds. Right? So we want to say every 30 seconds, we want to get PoE operational data subscribed to us. We want this in JSON IETF encoding as well, just like the other one. So when we expand this data model here, we see that there's a couple different lists that are in here to help us understand the type of data or the type of PoE model data, if it's for the switch, for the stack, from the module, or if it's for the port detail, right? And this is one of the more interesting ones, which actually tells us, at a per port level, how much power has been used. So I'm going to turn on this list for the PoE port detail and this container as well. So we should get all of this data, all of the pairs used, the Opera status, how much power, and the class on the per port, right? Per interface is what this shows up, which is going to be the name of the PoE interface. So we can build this RPC here, and we can see that this is a subscribe request, right? So subscription to PoE Opera data for PoE port data sampled every 30 seconds and encoded with JSON IETF. So this looks good. We can run this RPC, and Yank Suite is now going to go make a connection to the device. And then every 30 seconds, we should get a new payload of information. You can see if I scroll up just a little bit here, that we actually got the first payload of information. Right? So here's our actual subscribe request right here. Here is the subscribe response. And then here's the decoded response that's telling me that this 10 gig Ethernet port 1037 is currently using 41, I guess this is in watts, and that we have some other power utilization metrics here, like the power consumption and the max power draw for this interface. So here's all the data that we requested, and then here's when we're waiting, 30 seconds for another notification to come in, and here it is, right? Here's this notification. Here's some updated data or metrics. If anything's changed in here, if this was a 14 before and now we're consuming 15, we'll see that, and then we can draw that over time. Again, wait some time, get another update, wait some time, and then we'll get another update. So this is an example of receiving the model-driven telemetry from the device per this 30-second subscription interval.
Cool. So now I want to integrate this with the Grafana, right?
Mm-hmm.
Interface, or how do I go about that?
Yeah, so how do you integrate this with Grafana? So we actually have a GitHub repository here, the MDT, where we have examples, we have a whole lab guide in here for working with the various flavors of model-driven telemetry. So this is like a pretty comprehensive guide that starts with netconf telemetry. It goes into GNMI telemetry, which is what we're doing right now. And then it also covers gRPC dial out, the configured telemetry subscriptions. Okay, so once we actually go through and describe telemetry and the various telemetry collection options, then we go into the actual collection, which is what you're asking about, which is storing that data in Telegraph or in Influx, and then visualizing it with Grafana. So we have this section of the guide here that talks about using the Docker container. We have a config with GNMI that has the dial-in configuration and all the details here so that you can have a dashboard similar to this one right here that's collecting all of the common device monitoring options, version, the boot up, the span feeds and RPMs and temperature, all of this juicy details like CDP neighbors and MAC address table and all the interface counters and stuff. So all of this has been collected over GNMI and stored in the Influx database and then visualized here within the Grafana tool.
Cool. So all the steps to get this set up is in that GitHub repo that I share with everyone in the chat. So yeah, it's all here.
Yep, and there's actually another repository specific for GNMI. You can see I updated it just recently here, and this is the one that I'm actually going through. Probably should have shared this like at the very beginning of the session here, but this is the actual repository that's deep dive and focused on GNMI. So it's what we covered so far, which is well, maybe not the enablement, but the actual working with the capabilities, doing the get, the payloads, and the same thing with the set and the update of working with the host name.
Nice. All right, folks. So yes, if you want to follow along exactly what Jeremy has showed us so far, right? I've pasted in the chat window over there both repos, the MDT one and also the GNMI one, which we just went through. Thank you, Jeremy. Thanks for setting this up.
Yeah, for sure. So that is subscribe. The next thing is like getting even more like technical, which is the GNOI, which is the operational workflows. So let me just pause here for a minute before we get into this stuff. Are you ready?
I'm ready. Yes.
Any questions?
So yeah, one quick question on GNMI, right? You showed Yang Suite. What about I want to do this programmatically, right? Is there a Python library that's going to help me do the RPC connection, decoding all that data, or how do I do this in a programmatic way?
Yep, exactly. So like Yang Suite, if we go back to the slides here, I guess these ones, I have a slide here for Yang Suite. And it says, Yang Suite is a testing and validation environment, right? It's not for CI/CD. It's not for use like really in production. But what we have done is in all of the plugins, the protocol plugins, we have replays, right? So we have a replay here to generate a Python script, and we also have a replay to generate an Ansible playbook, right? So from this, I don't know if this one actually works for GNMI. I thought it only worked for netconf. Yeah, that's a bug or a UI bug, I think. But yeah, we have integration from GNMI to Ansible, not to Python. It's coming. So you can like save this playbook here that creates a subscribe request or updates the host name, and you can download this playbook and integrate this directly with your Ansible.
Nice.
Yeah.
And Python, you said, is coming up.
And yeah, Python is coming up. I don't think it's committed, so I can't say when it's going to come. But yeah, we're working on it.
Cool. There you go.
Yeah. So that's how you can get, and then you can plug this directly into another orchestration system.
Cool. Yes. Thank you.
Yep. Okay. So the next thing here is going to be the GNOI, right? So let's go down to that GNOI. So GNOI, it's relatively new. It's like a workflow API, right? So it's to handle these three services here, which is certificate management, operating system, so doing like code upgrades, as well as factory reset and doing wipes. And that's the one that I'm going to demonstrate coming up here, which is the reset.proto. It's one of the easier ones to demonstrate. Certificate management, we can probably have a dedicated session or day on that one. Like certificate stuff is always complex and lots of gotchas there. We do have a very detailed lab for cert.proto as well as for OS Proto and Reset. And those are linked actually in here. So first, I described the certificate management service, but what I actually want to go down to is factory reset, because it's going to take a couple minutes to actually trigger and do the stuff. So I want to kick that off while we talk about some of the other stuff. So GNOI factory reset, right? It's essentially an API call that's going to be the equivalent of like sending the factory reset all or factory reset switch all CLI on your device. It's going to like wipe, it's going to zeroize the disk, and it's also going to restore the operating system once the zero operation is done. So any artifacts that were on the disk are going to be gone, and you're going to be left with just a fresh operating system, a newly installed operating system. So let's go over to the demo environment, right? I'm going to log in here. Okay, so I'm logged in here to pod 27. The switch is up. I'm going to get onto the console of the switch, right, onto the serial line. And the reason for that is I'm going to trigger a reload, right? So I'm going to watch actually as this thing kind of goes down for a reload. Oops. And let's just get another session logged in here. So the way that the OS Proto works is against the GNMI API. So let's just do some validation that it's running. We can do a show run and include the GNXI section, and we'll see that it's enabled, or that we have the CLIs in the configuration. We have GNXI, secure server, and the server. So we have both services turned on, the secure and the non-secure. And we can check that by doing a show GNXI state detail, right? And it's going to tell us, yep, the server is enabled on this port. The secure server is also enabled on this port. And as we scroll down here, we'll see that the factory reset service is admin enabled and Opera up and supported. So it's ready to go. We can use the factory reset service. So how do we use it? I should have a helper script in here called GNOI reset.sh. So let's cat out this script and let's see what it does for us here. Basically, he's saying, go into the certs folder. And once you're in the certs folder, then call the GNOI reset tool, right? And call it against the IP address of your switch and authenticate using these certificate files. So let's do that. Okay, let's go into this folder over here, and let's call the GNOI reset that's at 10.1.1.5. That's where my switch is. Okay. So what I'm going to do now is just hit enter on this command to actually call GNOI reset. Okay, so what happens when I hit enter is I get something back from the API saying that the reset was called successfully. Right, that happens pretty much instantaneously. And when that happens, then we start getting messages on the serial console of this device that we're connected to, saying that the chassis is going down for reload because of a factory reset reason. Right, this is what we expect, right? Because we just triggered this factory reset. So now we actually get to see what happens as this goes through, which is to say, yep, it's going to go start the factory reset process. It's going to copy the operating system images, right? The stuff that's needed to boot the box back up. And then it's actually going to start the factory reset process of writing zeros, right? So it's going to unmount the disks. You can see here, disk 1, it's unmounted it, it's cleaned it up, and it's starting to write the zeros. And this will take a few minutes. Obviously, it takes a couple minutes to push all those zeros onto all those sectors. And it's going to happen twice. It happens first for disk 1. And in my case, I have a second disk actually inserted into my Cat9K. I have the SSD for some application hosting use cases. So factory reset is also going to send zeros onto that SSD, so that again, when the device comes back up, it's going to be exactly as it was coming from manufacturing, with no extra artifacts that are on any of the disks.
Gotcha. So you get these three operations supported now, right? The reset, what's the other one? The
You got operating system upgrade.
yeah, OS upgrades,
Yeah,
resets,
and certificate management.
and certificate management. All right. Are there going to be more operations that are getting added to this list? Like, what's the thought on that? What's the idea?
Yeah, so there are some OOPs that are defined. You can see in the slide here, we're supporting cert OS and reset on XE. Some other operating systems within Cisco also support file and system. So this is for doing like file copy and like reloads and managing the boot system. There's no plans to implement those on iOS XE. Those use cases are supported in the Yang data model ecosystem through the non-Google APIs, right? So through netconf and restconf, we're able to do file management and reloads and etc., but not with GNMI. And same thing, there's additional protos for specific features like BGP, like MPLS, and layer 2 stuff. There's also for managing the RIB and as well as for role-based access control. There's specific proto files that are defined by Google and by OpenConfig, but have not been implemented. So there's definitely lots of work that could be done if there's need for it, or if there's customers that are looking to use it. Then definitely we'd be looking to implement and support that.
Gotcha. And then that GNOI underscore reset, what is in that script? I'm curious.
Yeah, so this is, we're using the official tooling from Google. So the GNOI underscore reset is the reference tooling that is published as part of Google's repository for GNXI. So it's the official reference tooling, right? So it tells you, what options are supported, how to get this tool, right? This is Google stuff, so it's written in Go, right? You do a Go get for the tool, and then a Go install, and then you pretty much just call the binary.
I see.
Mhm.
Okay.
Yeah, so this is how the majority of the protos are working on XE, is that we recommend using the official Google reference tooling. And we have done some innovation in Yang Suite, actually, to be able to work with GNOIs. It's not actually baked into this version. There's just an engineering special that we were working on to manage and more programmatically do GNOIs, and really it was for testing, so we could programmatically test GNOIs with Yang Suite. That's another roadmap feature that could be coming into Yang Suite, because really, using the reference tooling, using the command line tooling is nice, but it's another tool that we need to manage. It's another set of certificates and flags that we need to manage, and that's why you see here that I have some helper scripts for I guess I'm up one folder here for the OS update and the reset, right? Because if we look at the OS update, there's a couple steps. I guess that's there's a couple steps where you need to do an install and then an activate, right? But it's the same thing that you saw with the factory reset, right? Instead of calling the GNOI reset, we call GNOI OS. We give it the flags, and then in this case, we actually give it the operating system bin file that the binary tool actually sends as part of the call, and activates when we give it that activate command.
I see.
Mhm.
Interesting. So interesting to see what Google is doing and what requirements they have for this.
Mhm, mhm. Yeah, because there's ways to manage certificates programmatically through data models. Same thing with the install, right? There's data models to do that, but Google comes up with their own API and then their own API definitions. So we're working to support them and support that ecosystem so that all customers can benefit from it.
Gotcha. All right.
Yeah. Okay, so this thing is still zeroing up here. It looks like it's finishing the erase now. So what's going to happen after this is that it's going to do a boot up, right? It's going to boot up, with no configuration. And, because we're talking about automation here, we're going to programmatically configure this device as it comes back up, right? We have ZTP, we have a DHCP service in here. So all the configuration is going to, programmatically get applied onto this device. And our DHCP service is over here. Our DHCP configuration is right here saying, option 67, point to this Python file for ZTP, right? This maps over to, a bunch of Python code over here that, does stuff, right? Configures the device, turns on some EEM applets, does some netconf API stuff. All right, so this is how we programmatically get the device, back to a good configured and working state.
Yep. All right. You were saying about secure ZTP?
About secure ZTP? Yeah, I mean, this is this is classic ZTP. So we're just loading the config file. Like if I go back to this, just straight up from HTTP, web service on the LAN. We are also supporting the secure ZTP service, where this is a HTTPS URL that the device will go and access securely using certificates, using intermediate certificates and ownership vouchers that are assigned from Cisco to you as a customer, so you can have the secure bootstrapping option.
Can people find somewhere the steps they need to go through to get secure ZTP?
Not right now. I mean, it is published in the configuration guide, the requirements for secure ZTP. There's a bootstrapping service or bootstrapping server. We have one available as part of the XR or MIG software offering. I forget what it's called for the bootstrapping service, but there is one available from Cisco. But it is a RFC standard. So the bootstrapping service can be created per RFC. And really all it needs to do is just pass one data model to the device, which defines some settings that are passed through to like the upstream authentication service.
Gotcha. All right.
Yeah.
So
Yeah, so that is the GNOI. If we go back to the lab guide here, yeah, your question was around, the tooling. So I did put the links to the GNOI reset tooling as well as to the actual like factory reset specification, right? So if you want to go and like read the proto file that we've implemented, like this tells you, stuff about the factory reset, the zero fill, and like, what other options are defined in the actual API itself. Right, this probably isn't needed for most users. Most users are just going to be good enough just to use the the binary client that's available. But yeah, I put this in for factory reset, and then same thing for the certificate management service. Right, the actual cert.proto definition is here, and then there should be some details here about the actual the client that we're using as well. Yeah, which is here, right? The actual GNOI cert. So that's over here in GitHub, right? So same thing as GNOI reset, right? Just go and go get the client, go build it, and then we're able to run it with the flags. Yeah, there's quite a workflow with the cert.proto to be able to push the certificates. You have some options for like rotating and revoking as well if you're getting into some advanced use cases. And then same thing with bootstrapping, right? We can actually turn on GNOI at day 0 securely, and then send it a certificate that actually gets automatically installed and then used for all of the subsequent API operations. So it's a really powerful feature used in automation where you can, what we're doing, just like what we're doing here by bootstrapping the device using automation. We can bootstrap the device to turn on GNMI and to turn on securely, and then to also send certificates at it.
Right. And once you have the certificate on them, you can authenticate programmatically and you can push configuration, change, get operational data, and all of that.
Yep, exactly. Yeah,
Cool.
so I think that's pretty much what I wanted to demo, which was the reset capabilities, and then just to talk about some of the other ones here. And finally, we're just waiting for ZTP to complete. So what's happened here is that it's gone out and done DECP, and that DECP has come back with that ZTP, right? The ZTP simple pie that we looked at up here that has all of the configuration in it. Well, what's happening here is that now we're actually running that script, right? And we're actually affecting the configuration by turning on EM configuration, and then now we're actually going configuring VLAN SVIs and interface ranges and things like that.
Default routes, of course.
Yeah.
Yeah.
Yep. And here we are actually turning on GNMI, right? We're saying, hey, do a secure init, allow me to use self-signed certificates, right? And then turn it on. So now we can go on to this and start working with it without any barrier to creating TLS certificates, right? This is our example for in the lab. And I did post an example in the lab guide for running this in production. Definitely you don't want to do things like this in production, which is use self-signed certificates. And then similarly, as I mentioned at the beginning, like the ACL and the RBAC, those are security considerations to put on top of all of this too.
There you go. So you have your IPs on the interfaces, you have GNMI enabled, app hosting.
Yeah, turning on netconf API so that we can do some, actually as part of day 0, we're sending a netconf payload to just validate that the configuration has been applied by checking the device host name, I think is what it is. Yeah. So if we go back to this here, yeah, we turn on the netconf API, we save the configuration, and then, yeah, we run this Python script to validate the host name, and when we actually get back this block of XML saying, oh yeah, it's pod 27 that was just configured. Turn off the guest shell. The script is completed successfully, and we're in business, right? We're switching packets at this point, right? We see some details from syslog and from some of the stuff that we've configured, but if we go back to the IP network here, we should be able to ping our switch, right? And it's back connecting, right? We can telnet into it. Just do a show version, just make sure we're on the right switch here. Yep, it's been up 6 minutes here. This is the one here that we just reloaded, and it's back in line. We don't need to be on the serial console. Don't need to be on the serial console. Give it a quit here, right? We can just be back on the IP network like we are here, and we're in business.
That's really cool. So part of your ZTP, you're actually instantiating a guest shell instance and running that netconf to check the host name, making sure that everything went well. That's really cool.
Yeah, exactly, right. And this is some innovation that was put in to guest shell and ZTP and one of the more recent releases, so that you can not only send CLI like we're doing here using the Python or the Cisco Python CLI module that's built into iOS XE, but you can also send API calls to netconf, and you can send just raw block of XML. And we have these examples in GitHub here as well. Right, you'll see that there's one for zero touch provisioning. The actual script that we're looking at here should be in here, ZTP netconf, right? So this is an example. The actual get the host name example is in here. But I think I have this one here from the XE Labs, right? I actually have the exact script that we're running that you just saw. I think this might be slightly older version, but all of the stuff, all of the examples are going to be in here. And we also have this solution example for ZTP that has like, a more deep dive example of, some pretty advanced use cases where we're doing like software upgrades and stuff as part of the ZTP process. But this is, again, getting a little further away from GNMI now.
Yeah. Okay, cool. So anything else about GNMI, right? We've seen Yang Suite, we've done get sets over GNMI. We show the Ansible generation, right? Ansible playbook generation option over there.
Yeah, there's one more thing.
Yes.
This thing, gRPC tunnel. Have you heard of this?
No, what is this?
Okay, so what this is this creates a tunnel from iOS XE, from your switch, out through firewalls, out through whatever network issues you got, to a tunnel endpoint server, right, to some destination. So the idea here is that if you have a firewall in front of your switch, or you don't have network access into your switch, you can configure the switch so that it'll create a session and it'll keep that session up. It'll create this tunnel out to the tunnel server that you can then ride in on, or you can then get into the tunnel, and you can do GNMI operations and services within the tunnel.
I see. So you kind of have like a bastion host or like your management or configuration server. And instead of connecting from that server to your switch, the switch kind of automatically connects back to your bastion host using this gRPC tunnel functionality.
Exactly. Yep, exactly. So I have a call flow diagram in here as well. Basically, we have a tunnel server host on the right and your iOS XE on the left. Right, this tunnel gets created, and when we ride the tunnel, we go through the tunnel client, and there's a socket, which brings us back to the listening port. And the listening port is typically where what I've been using in this demo is the listening port, right? The 9339 or the port 50052. Right, and that's how we typically go in to do GNMI or CERT or OS or whatever GNMI services. But when we have the tunnel, then we go through this the client port, through the tunnel client, and then we get into the listening port to actually effect changes.
Nice. Yeah, because this way you don't need to open your firewall from outside to anything, right?
Exactly.
You keep it locked in, no ports allowed, but you still get connectivity because the switch initiates the call to your server host. Cool.
Yeah.
Nice.
Yeah, exactly. Yeah, so we're demoing this in the lab in this pod environment that I'm in over here in pod 27, and in all 30 of the pods. We have the configuration up in here somewhere, but it's not quite ready to demo, at least not for the masses yet, or just because of blockers on our side. But the feature is built, and it's a shipping feature. Definitely, we have customers using it already, so. Definitely you can deploy that in confidence, because again, customers are deploying this when they have a lot of devices and they don't have network access into those devices.
Yeah, I could definitely see this being very useful. All right, gRPC tunnels, we've seen Yang Suite, we've seen GNMI, we've seen operational workflows with GNOI, we've done a factory reset, zero in the disk on that switch, then use ZTP to bring it back online. Part of ZTP, we had your regular config, but we also had instantiating a guest shell instance and running a script that checks the netconf host name on that switch, making sure that the ZTP correctly completed or worked correctly. So you got that going, and then the gRPC tunnel, which is another very cool technology of not having to open any ports on your firewall if you want to connect to your device, but the device actually initiating connections back to your management server. Cool. So what else did we? Yeah, I think that's what we covered. Thank you so much, Jeremy. It's really cool.
Yeah, man, it's a lot to cover. I think we just scratched the surface too. So there's lots of links and resources. And if you do want to get hands-on, definitely reach out. We do have labs and environments available to support this type of training.
So yeah, exactly. Where can people find this? Are these labs on Cisco U? Some of them will be on, well, part of it will be on DevNet also under the Learning Labs. And Jeremy and I and Story and the team are working actually on upgrading the sandboxes to Cat 8 KVs for folks, right? The DevNet sandboxes that you can use. Uh, Ioannis, hello from Greece. Hi, Ioannis. Thanks for joining us.
Oh, hey.
Uh, so, right, we're working on getting the sandbox, the DevNet sandbox updated, and you'll
Yeah.
have Grafana in there. You'll have Telegraph. Basically, you have the tick stack, Telegraph, Influx, Grafana, and then you get a nice dashboards that you can configure, monitoring. Like Jeremy was showing, you could monitor PoE, power consumption on your ports, or whatever you want to monitor over streaming telemetry. Right, so you get streaming telemetry data coming into the dev box. Yeah, it's cool stuff. And then we're also reviewing the learning labs, and we're sprucing them up, bring them up to date, making sure that they work for you folks. There you go. The tick stack.
Yeah, tick stack here. Yeah, the amount of collateral updates that we have in flight is getting out of control. Definitely, like we're as you're saying, right? We're working on sandboxes and learning labs, and yeah, this content will be in Cisco U. We're working with those teams as well to get this content there and get labs there. Same thing with dcloud, right? We're working with dcloud team to ensure that there's lab guides and environments there that you can just reserve on demand to get in here to train with this stuff.
So lots of content coming out, learning labs, sandboxes, GitHub repos. I've pasted 3 of them here. So github.com/Jeremy Coho basically will get you to 100 plus repos that Jeremy has in there. Have a look at them. There's model-driven telemetry repo. There's the GNMI repo. There's zero-touch provisioning that we've talked about. So lots and lots of great content in there. Let us know what else you want us to cover, right? So with iOS XE, we've covered now Google Tech. Thank you so much, Jeremy. Previously, we went with Story and we talked about the Terraform provider that iOS XE has now, right? So we've seen how you establish a VPN tunnel from your iOS XE device back into AWS using a Terraform plan, a Terraform provider. So let us know what else you want to see, right, on iOS XE specifically. Lots and lots of content. We'd love to bring Jeremy and Story back to share more of this technology with you. But if you have any specific requests, do let me know, and we'll prepare, we'll get ready for you, and bring them back in the next session. Until then, thank you so much for joining us today. Next week, hopefully, we'll be back on track. We're gonna have to, move these live streams for different reasons, but hopefully next week we'll be back on track. Wednesdays, 9 a.m., we have Sherry coming back and talking about Catalyst SD-WAN and Azure deployments, CI/CD pipelines, how you actually build your images for your Catalyst infrastructure, Catalyst SD-WAN infrastructure into Azure, how you deploy your SD-WAN fabric in there, and how you have that integrated to a CI/CD pipeline. So see you folks hopefully next week. Back on track Wednesdays at 9 a.m. Pacific. Jeremy, thank you so much again for your presentation here.
Anytime. You're welcome. Call me.
Super great.
DM me. Corner me. We'll answer any questions, help you out, anything that's needed. We're here.
We'll do. Thank you so much. Thanks, everyone, and see you on the next one. Thanks, folks.
Bye.
Take care. Bye.